All right, physics honors students. So I'm going to do a couple of these problems from worksheet 4 for you here. Kind of show you how we go about doing them. I'm just going to read them. I don't have the paper with me here at school, so I'm looking at it on a computer off to my side here while I make this video. So number 10, a spacecraft orbits at a uniform speed of 1,050 meters per second. The firing of one of its rockets gives it an acceleration of 57 meters per second each second. What will be the new speed of the craft after 12 seconds of rocket burning? All right, so, useful. First of all, maybe we draw what it looks like. So its initial velocity is 1050 meters per second. The fuel's it's gonna burn some fuel, right? And it's gonna accelerate, and we want to find the final velocity, right? So that's our unknown. It accelerates, right? I'm gonna draw some blocky arrow for acceleration at a rate of positive 57 meters per second, which is meters per second squared. And it does that for a time of 12 seconds. So it's kind of what the sketch of the problem looks like. I'm going to make the organizational table here, all right? V initial, V final, V average, acceleration, displacement, and time. So initial velocity is 1050 meters per second. Final velocity is what we're looking for. Acceleration is 57 meters per second squared. The time is 12 seconds. Now, I'm going to erase the drawing here. At this point, if we were at school, I would give you the equation sheet. I think I have it here somewhere. So maybe if I will, I'll post it in the topic if I can find it. But we have a few different equations, right? So I'm gonna write down the basic equations we know over here for you once, and then we can talk about them. So average velocity equals displacement over time. All right, which we can rearrange to be average displacement equals average velocity times time. We have the definition of acceleration. Acceleration equals change in velocity over time, which can be arranged to look like V final equals V initial plus AT. This one we often write as delta x equals average velocity times time. We have average velocity equals V initial plus V final over 2. And then we have the two new ones that I derived for you in the last video, which were delta x equals 1/2 AT squared plus V initial times t. So it's 1/2 AT squared plus V initial t. And V final squared equals V initial squared plus 2A delta x. Twice the acceleration times the displacement. So what we're really going to try to do here, note that in the last worksheet we did stuff with graphs. This one I'm going to focus on just using the equation. So we have the graphical way of doing things, then we have the equation way of doing things. And some people like one better than the other. So we are looking for the new speed of the aircraft after 12 seconds of firing its rocket. So this is what we're looking for, V final. That's our big unknown. So let's see if there's any equations here that have time, acceleration, V initial, and only are missing V final. All right, so I have this one that has V final is what we look for. We have V initial, acceleration, time. That looks like the one to use. But let's just check things out. Why wouldn't we want to use this one? Well, we don't know delta x. This one doesn't have V final in it. This one doesn't help us because we don't know the average velocity. So this looks good to me. So I'm going to write that equation down. V final equals V initial plus AT. And then I'm going to substitute in with units. So V final equals 1050 meters per second plus 57 meters per second squared times 12 seconds. So on the regents, this is what you have to do. You have to write down the equation, you have to substitute in the numbers with units and then solve it. So 1050, so 57 times 12, and of course I don't have a calculator down here with me right now, it appears. So I'll have to wing this in my head. So 57 times 12, okay, so 50, that'd be 514, no, 500 and, 614, something like that. I don't know. 614 meters per second. Seconds cancel. 1050 plus 614. Actually, you know what I can do? I can check it here. Hold on a second. You got a calculator on the computer. Very good. All right, 684. 684, you fool, Harmon. 684 is 57 times 12. My bad. Add them together, you get a final velocity of 1734 meters per second. That's kind of a warm-up. That's a pretty easy question. All right, so I'm going to leave these equations up here, and I'm going to try to work over on this side of the board and do another one here for you. I'm actually going to do 11 and 12, and then that'll show you how to use all three of the main equations. Really, the main kinematic equations are this one, equations of motion, and that one. Those are kind of like your, and then, you know, this one, and this one are kind of basic definitions, right? These are the bigger three main equations, and then average velocity, acceleration, and average velocity. Those are just kind of the basic definitions. All right, so the next one says, rocket accelerates upwards from rest with a uniform acceleration of 4.2 meters per second. How far will the rocket have traveled in 8 seconds? So we got a rocket, starts off at rest, right? And it takes off, and 8 seconds later, what's its final velocity? Well, v initial equals 0, v final equals, I don't know what, has an acceleration of 4.2 meters per second squared, and I'm writing small here because I'm going to make a table over here. All right, so I'm going to make the organizational table. One big line, then 1, 2, 3, 4, 5 smaller lines. V initial, V final, V average, acceleration, displacement, and time go in the top there. Sorry, got a little bit off there with the average symbol. So it starts at rest, so that means V initial is 0 meters per second. Accelerates at a rate of 4.2 meters per second squared, and it does it for a time of 8 seconds, right? 8 seconds. Okay, and we're looking for the displacement, so that's our big unknown quantity. I don't know anything about final velocity. I don't know what that is. I don't know average velocity, and I don't know displacement. So let's see if we can find an equation that we can solve for displacement. Now, yes, we can do average velocity times time, but we don't know the final velocity, which you might be able to say, okay, well, I can find the final velocity by using this equation, which you could, but I want to try to get this all done in one step. One step. So let's see if we have one that has delta x, a, t, and v initial in it. Oh, what do you know? El Grande. Solves for delta x. I have a, I have t. I know v initial is 0. All right, so let me write the equation down. Delta x equals 1/2 at squared plus v initial t. The initial velocity is 0, so delta x equals 1/2 of 4.2 meters per second squared times 8.0 seconds squared plus, now it's 0 times 8 seconds, right? So this term is just 0, goes to 0, goes to naught, sometimes people will say. It goes to 0. So really we just have to calculate this. So delta x, 8 squared, right, is 64. Half of that is 32. 4 times 32 is about 108 meters or so. Probably 110 would be the answer to 2 sig figs, right? Because we don't have more than 2 sig figs here. And that's the answer to that one. So this process is kind of repetitive. You have to be able to picture the physical situation in your head and then translate that situation to this table. So hopefully I'm going to do one more showing you the v squared equation, and we'll go from there. Now let me see here. There's another v squared one. Let's do number 18 actually. 18. So this will be number 18. So it says a rocket traveling 50 meters per second accelerates at a rate of 2.0 meters per second per second. So traveling at 50 meters per second, that's the initial velocity, 50 meters per second. So it accelerates at a rate of 2.0 meters per second squared. What is the speed of the rocket after it has traveled 500 meters? So it's asking us, okay, 500 meters of traveling, you know, if it's going to accelerate over a distance of 500 meters, how fast will it be going? How fast will it be going and how long will it take to get there? So this is actually going to be 2 steps. So I already I'm not given time here, right? So I could try to maybe figure out the time, you know, but that gets to be a pain. So I don't have the time. It's a good clue that you need to use v squared or the timeless equation. So first thing I'm going to do is figure out the speed. So v final squared equals v initial squared plus 2a delta x. I write the equation down. All right. V final is what we're looking for. So my marker got kind of wacky there. V final squared equals v initial squared. So 50 meters per second squared plus 2 times 2 meters per second squared times 500. So, okay, so let me see here. 500 times 2 times 2. All right, so that's 4 times 500. That's VF squared equals 50 squared is, let's see, 2. Let me get something here. Where's my dashboard? How do you do that? I used to be able to do this. Anyway, darn it. 2,500 all right, plus, what is this, 2,000, right? And I've dropped the units here, so v final equals radical 4,500, which ends up being about 67 meters per second for the final velocity. All right, so I'm going to write that now up here, 67 meters per second for the final velocity over that distance. All right, so now I got to figure out the time it takes to get up to that speed and cover that distance, right? It's going to take less than 10 seconds, that's for sure, because well, the average velocity here, you know, such that, okay, if it was moving 50 meters per second, in 10 seconds it would go 500 meters, but since it's getting faster, it should take less time. So there's a few ways to do this. I guess the easiest way to do this is probably acceleration equals change in velocity over time. We know the acceleration, we know the change in velocity, we're looking for the time. So we're gaining 17 meters per second at a rate of 2.0 meters per second each second, right? So meters per second cancel, meters per second cancel. 17 over 2 is 8.5. Oh, I'm sorry. I'm speaking too fast here. I have to solve this for time, right? All right, so time, cross multiply here, equals delta V over A. So that's plus 17 meters per second at a rate of 2.0 meters per second squared, or meters per second. Meters cancel, 1 of the seconds cancels. You get 8.5, 1 over seconds, which is 8.5 seconds. 1 over seconds is, well, the seconds goes upstairs. So that's an S. Sorry about that. All right, so I'm going to stop the video here. Talk to you later.